Yep. Okay, so welcome. We've heard a little bit about the brain. And I'm going to take you on a different journey through the brain, because I really believe if we understand the brain, there's a lot of things we can achieve. And some of the things we're trying to do for either sustainable futures, change the world, increase our consciousness, are actually slightly wrong or slightly misplaced because we're not doing the right thing. So I'm going to take a slightly different approach. I'm not going to talk about consciousness. I'm not going to talk about how to change your brain, but I will talk about the brain. And a really important thing to think of when we look at the brain is that actually most things in the brain are there for a very good reason, and most of those things have an upside. Some of them are really good, and a lot of them also have a downside, which means there's kind of a negative impact or a negative impact depending on the context you're in. So it can change, yeah. So that's the basic principle. So from the brain's perspective, we start, up left, we've got this DNA stuff, and that DNA stuff goes over and, stimulates stem cells to grow into different forms of brain cells. And those different forms of brain cells, and this is interesting, and I saw a little baby over there, because as the brain's forming, something you probably don't know, there's something called a neuronal migration, where these brain cells will actually start shifting and moving through the brain to find their position in the brain. Once they've found the position in the brain, they'll go down here and they'll start to connect together and get connections. We heard about neuroplasticity before. And then they'll start firing together and activating based on what's happening in the world. And that goes back, as we just heard previously, and starts wiring again. So it starts activation, wiring process, activation, wiring. Most of the things the brain learns as a baby, we think about some conditioning, but it learns other patterns as well. For example, we'll learn a pattern that standing on the floor is always hard. It's always there. We'll learn things like putting things on tables is easy. Artificial intelligence has real difficulty with this. Some of the most obvious things in the world, the brain is fantastic at doing. Now I'm going to take you on a couple of other little things, and let's look at some of these interactions, and I'm going to jump between these different levels, from the micro level to the macro level, and backwards and forwards, because they're interacting with each other all the time. And sometimes we misunderstand that or misinterpret that. So if we take this gene, for example, COMT-V158M is known as the warrior or worrier gene. And that impacts things like dopamine in the prefrontal. Dopamine is chemical which focuses attention in the brain, but attention helps the wiring process in the brain. The dopamine also helps with emotional activation in the brain, positive or negative. That means if you have a lot of that stuff, you tend to be very sensitive. Increased sensitivity to the positive stuff, and increased sensitivity to the negative stuff. So you have increased sensitivity. Now that's kind of like, as I said, it's kind of like a good thing and it's kind of like a bad thing at the same time, because it makes you more neurotic. We were talking about speaking to strangers, the activation. If you're on this side, it will activate much more negative emotion when you're meeting new people, for example. So it makes you more neurotic. However, being neurotic sounds like a bad thing. It's called emotional sensitivity, politically correct in science now. Sounds like a bad thing, but it increases your short-term memory, because high emotional impact increases memory. It also increases plasticity, particularly with age. So if you're neurotic, you've probably got better short-term memory, and you're better at learning in age, which is probably a good thing to do. Another interesting gene is this Notch2NL. Great, it's a gene which is now assumed to have directed humanity's progress, because it's one gene that's not found in monkeys. And this gene does something strange, and the strange thing is it inhibits the growth of stem cells, as I mentioned previously. That may sound like a bad thing, but the good thing with that is it allows production, that decreased production allows more production later, which means we can produce more brain cells, which is associated with greater intelligence. It also increases the chances of disorders. Various disorders, bipolar, schizophrenia, are related to this impact of building too many brain cells in too many places, so we get the negative side as well. Now, if we go back and look at some other things, and we look at the similarity between the simplest animals and human beings, I find this also a fascinating thing to look at. Anyone know what C. elegans is? C. elegans is the most researched animal in neuroscience, and it is a worm. It's researched because it has only 300 neurons, so it's really easy to find them, and it's really easy to research them and find out what they do, and you can map a whole organism. What's interesting about the C. elegans and the similarity between human beings is they have the primal form of some of the behaviors that we have. The primal form that the C. elegans has, for example, is it has an exploration process. Put it in a petri dish with some food, and you'll start to eat the food, and then it will start to do something strange. Before it's finished the food, it will already start exploring around about, looking for more food. It's an exploratory process, driven at the simplest organisms that we human beings also have exploration, and that drives in human beings things like curiosity. So this concept of curiosity we can see in the simplest organisms and in human beings as well. If we look at exploration, though, it's part of a need and a larger driving mechanism in human beings, which is the desire for orientation. We're looking for orientation as one key driver of all human beings. And if we look at this pattern, we can see from the lowest level of behavior, chemical, exploration, social orientation, and the highest forms of behavior, which are learning and knowledge, are driven by this desire for orientation. One key level. Below that line, it's a human element, just present in human beings. If we mapped that to other needs of human beings, we'd find similar patterns. And this is just a part of the research I've been on, looking at these as 5 core drivers of human behavior, which will be self-esteem, control, orientation, attachment, relationships and bonding, and pleasure. 5 needs. If you have those 5 needs, back to the passion and purpose, if you have those 5 needs fulfilled, you're going to be a happy person. If you don't have those 5 needs fulfilled, you're going to be an unhappy person. Quite simple. And you can apply that anywhere. We have a drive for this, and some of those drives are negative drives. The drive for status has also many negative impacts in the world, but it's embedded in human beings in this desire for self-esteem. And this is why we say those 5 needs are core emotional drives of every single human being on planet Earth. And then if we go back to the micro level again, we see something interesting again, because we looked at a bigger need, and we look at this, and these are neurons, and he says persistent stress changes brain architecture. That's what it says. If you look at that neuron at the top, you can see lots of wiring, lots of connections. There's been lots of growth there. If you look at the neuron at the bottom, under toxic stress, it has damaged neurons and fewer connections. This is from the Harvard Center for the Developing Child. There's been a lot of research in this. You may wonder what toxic stress is or was in this particular case. In this particular case, toxic stress was removing a rat pup from its mother. And that toxic stress caused disruptive growth of neurons. And you can think of that dramatic impacts. Interestingly, the research was also done in the rat mother and the rat pup, and saw similar effects in the rat pup and the rat mother, inhibited growth, disrupted growth of neurons. So we're going back from the biological to the bigger drives that we know are important, but they're important because they're natural drives the organism is driven to do, as I said, 5 needs, but it's also fundamentally important because it impacts that level, which is the biological level. Now, if we think of this as well, these drives, we've got to drive to achieve more of those 5 things. You'd like to have more, self-esteem, value, appreciation, recognition. We'd like to have more self-control. We spoke about self-control previously. We'd like to have more of this. But we also want to protect it as well. There's the downside. Achieving it is related to positive emotions. If I achieve more of this, it's going to be a good feeling. And protecting it is related to negative emotions. You know, if I have this damaged, if I'm put down, it's going to feel really, really bad. So positive, negative emotions. Now, I'll come back to this in a second because I'm going to relate this to something else. And I'm going to relate to something we rarely look at in the world of orientation. We often look at various social orientation mechanisms or learning or knowledge. But if we look at a key function of orientations is to give us worldviews. How do we look at the world? How do we see the world around about us? What's our outlook out there? And Tompkins' polarity theory is quite an interesting theory. Started in the 50s and 60s, almost never read by many people. Tompkins was quite a famous professor, actually. And he spoke about humanism or humanists, and normativism and normativists. And he called them two fundamental worldviews. And the humanists are human. You know, we see the world as human, and I can guarantee all of you here are on the humanist side. It's quite easy. I don't really have to do any research here. I can say just because you're here, you're going to be on the humanist side, which means you have more positive effect. You're less authoritarian. You're less socially dominant. You're more open. You're more agreeable. Conversations are going to be really easy outside. We're going to be open to other people. We're going to be interested in meeting all these fantastic, wonderful people, and we're more empathetic. So we relate to people really well. But there's the normativists. And what are they like? Well, basically the opposite. They have less negative effect, less positive effect, more negative effect. Negative effect are things like anger, you know, things like that. They get rage, they get really angry all the time. More authoritarian, more socially dominant. They want to be in control. They're less open, actually more introverted, interestingly. Less agreeable. Higher neuroticism, which I spoke about previously, higher activation of emotions, and particular activation of the threat emotion. Now, this also becomes interesting if we take that viewpoint. He said these relate very strongly to political standpoints. Traditionally, particularly in the US, and this is a particular US thing, as we all know at the moment, there's a kind of left-wing thing and there's a conservative right-wing thing happening. It's a two-party country, so there's two dominant forms two dominant political forms. Two forms is actually a really bad way to look at politics, incidentally, but just the way it is traditionally. Okay, so, and starting in about 2004, there were different pieces of research into the political brain. Putting these political partisans, you know, saying someone's really strongly conservative or really, really strongly democratic, put them in a brain scanner, give them stimulus and see what happens. And interestingly, activation of two brain areas predicts with 82.9% accuracy political affiliation. 82.9%, that's higher than parental society or parental influence. Those two brain areas are an area called the insula, area called the amygdala. Many of you may have heard of the amygdala as being a threat and fear center of the brain. Threat activation, fear activation of the brain drives political standpoints. It's easier to predict by looking at the brain than it is by looking at your parents. Normally we assume it's parents, even though there's obviously a genetic influence there as well. So this is interesting because we've got this, and we've also got, just as a side note, we've got disgust sensitivity is something that's also been recently researched with conservative viewpoints as well. So what does that, it becomes interesting then, because if we do the opposite, if we go the opposite way around and just activate threat or fear or disgust, we find that political viewpoints shift to the right. Hence why politicians are very good at activating fear, threat, and disgust, you know. And they're normally, obviously normative, is they're normally very angry, full of rage, and they communicate this, and it actually shifts political opinions in society to the right of society. But the really interesting point is this now, and this is something I'd really like to draw your attention to, is we've got the wrong language. If I took something like the immigration crisis or immigration issues, if we're humanists like us, like all of us, You'll talk about empathy, you'll talk about humanity, you'll talk about diversity, the power of diversity, the creativity it gives us, the benefits we have to society. The problem with that is a normativist brain does not respond to that, because they respond to that. Their brains are in fear status, they've got identity threat, they've got fear, they've got morals, disgust, it's all activated. So if we speak to normatives in humanist language, it doesn't work. We're doing the wrong thing. We can't activate those brains by speaking in our own language. We are speaking to our own people, our own group of people, and we all agree anyway. So we go, yeah, come on, we have to be human, we have to look after these people. But those brains don't get it, because it's a simple brain wiring, higher sensitivity, higher activation of those brains. If we took it over to something like climate change, we'll see exactly the same thing. Particularly in the US, you see this has become a politicized issue. Climate change denial on the right, openness to climate change on the left, the humanist approach. We talk about the good things of climate change, the good things that happen to us, the positivity. Those on the right have fearful brains. They're worried about threat, they're worried about danger, they're worried about identity, they're worried about their morals, they're worried about those things. However, if we look at the research, we know we can communicate to them in the right way. If we do the right thing and use the communication correctly, we can do the right thing. And interestingly, the research shows this. Normatives do respond positively and change their opinions on climate change if we frame the language in the right way. And by framing language, we need things like draw attention to consensus. We forget to mention that 99% of climate scientists know there's climate change, believe it. And conservative climate scientists also believe it. So we forget to talk about consensus. Educated conservatives will follow consensus because they're consensus-driven people. When we talk about the past, they're better. Not we're going to take a great future for the climate, talk about how it was great in the past when the buffalo rolled across plains in the West and we had our great American landscapes. They respond really well to that. They don't respond to, we've got to make the future better for our children. They're much worse. The past was great. We were great in the past, as we know, the political message. When we talk about native breeds, native concepts, our own animals are dying, our own things which are true to us, to our nation, they are dying. Then they respond to that. And they respond to other features like being guardians, taking our responsibility for God's work, and protecting what God has given us. They respond really well to that. So we're communicating to these people in the wrong way. So my bigger message then is simply that, is we've got different types of brains, and that's driven from genetics at the lowest level, it's driven from neurons at the one level, it's driven by these big drives at the other level, and we have to enable those brains to talk together better. And if we want to make a change in the world, we have to not just talk to our brains, but we have to talk to other people's brains and activate their brains to get action. And the science shows we can do that, incidentally. So the big message is this. I really want us to use our brains to understand brains and communicate effectively. And with that, we can help elevate humanity. Thank you.